Hello everyone, welcome to Cambridge Guru once again. Today we are starting with the new unit, chapter number 10, Vectors. This is the second last unit of your syllabus 9709, Pure Maths, paper number 32. Okay, so without wasting any time, let us start. So basically, is the basic definition of vectors is that there are two types of physical quantities. One is scalar quantity and another is vector quantity. Scalar quantities are those quantities which have only magnitude and there is no direction in the quantities. For example, mass, right? The mass, it does not have any direction. Then we say distance or the speed, right? So these are the physical quantities which do not have the direction. So we say that these have only the magnitude, that a mass of, let us say, 5 kg or 10 kgs, right? On the other hand, we have other quantities which are called the vector quantities, which have both magnitude as well as direction. For example, force, right? Displacement, velocity, acceleration. All these are the quantities which have magnitude as well as direction, that there is some direction in this. For example, if I say that the force, gravitation force, right? Gravitation force is, its direction is towards the center of the earth, if we talk about the gravitation force of the earth, right? Or if I applying a force on this pen, then if I apply force in this direction, so pen is moving is in this direction, right? So as you know that force and acceleration are interrelated to each other, there is a relation between force and acceleration. So if I apply a force in this direction, so the body will accelerate in this direction. So as I'm saying that in this direction, that means in this physical quantity, a direction is there. So we are not talking much about the physics in this, but we have to deal with the mathematics that is involved in vectors. All right. So there is a basic definition that vectors, first we are dealing with vectors in two dimension, mean vectors in a plane. So it says that in two dimension it is common to represent a vector by drawing of a straight line with an arrowhead, right? So if I'm drawing a vector like this, and this is the starting point, so I will say that this is the magnitude, means whatever is the size or the length of this arrowhead, this is the size of that vector, and the direction is measured, the whatever angle this vector is making with the positive direction of x-axis, so we say that it is moving in this direction, right? Or you can say the 30 degrees, whatever is the value of this angle theta, right? So the length represents the size or magnitude of the direction of the vector, and the direction is indicated by the line and the arrowhead. Direction is usually given as the angle the vector makes with the positive x-axis, with the anti-clockwise direction taken to be positive, right? So if this is the positive x-axis, right, and this is the vector direction, so I will say that whatever angle this is making with the positive x direction, measuring the angle anti-clockwise. Okay. The vector in figure 8.1, this figure has magnitude 5. So the length of this is 5 units and its direction is plus 30 degrees. And this is written in this form 5, 30 degrees, right? This 5, 30 is the, you can say, the notation or the general form of writing these two quantities. One is the size. So the first, you can say, in this ordered pair, the first value is the size of the or the magnitude of the vector, and second element in this ordered pair is the direction. So generally these are written with r comma theta notation, where r is the magnitude of this vector and theta is the direction, right? An alternative way of describing a vector is in terms of components in given direction, right? I'm not talking about the physics, that what do you mean by component in this. So if, let us say, you have the coordinate axis like this, that positive direction is x and this is the y direction, and if I say that there are something which is called unit vector, okay, there is something which is called unit vector, Unit vector, as the name is suggesting, that its magnitude is just 1. Okay, so if I say that there is a physical quantity which is having only a magnitude of 5 units, and if I multiply this 5 with a vector, with a unit vector, that becomes 5 multiplied by that unit vector denoted by a cap. Okay, so if I take the magnitude of this, right, so magnitude, as the vector is having the magnitude as 5, because initially it was a scalar whose magnitude was 5 units. Okay, so magnitude of this vector quantity should be 1, but this process of multiplying a unit vector with a magnitude or with a scalar quantity, that becomes a vector quantity. It gives the direction to that to that scalar quantity. That is the meaning of multiplying a scalar with a vector. Okay, that scalar quantity becomes a vector quantity, and direction is introduced by that vector which you have multiplied. Okay, and the direction of that 5a cap, for example, of this scalar quantity, now becomes the direction of this vector, now becomes the direction of this whole vector 5a cap. Okay, so basically unit vector is a vector which we use to multiply with certain scalar quantities to make them as a vector quantities, and their magnitude always remains 1. That's why the name is unit vector. So we have the unit vector, general unit vectors, which are in the x direction, y direction, and z direction, if you are taking into account the third dimension also. But in this case, since we are dealing with 2-dimension cases, so we say that in the positive x direction there is a unit vector which is denoted by, we used to pronounce this like, not used to, but we usually pronounce this as I cap. Okay, so this vector is denoted by I cap, and a vector which is unit vector which is in the y direction is denoted by j cap. Okay, similarly, if there is a third dimension, so the unit vector along the z direction, z axis, that is denoted by k cap. So I, j, and k, these are the standard unit vectors along the coordinate axis. Okay, so if there is a scalar quantity 5 and I multiplied this by I cap, so now this becomes a vector in the positive x direction whose magnitude now is 5, right? So if I have to represent this, so I can represent this by this green vector now, that this green vector is 5I cap, right? Similarly, if there is a vector, let us say 2I cap plus 3j cap. The meaning of this 2I cap plus 3j cap is just like coordinates x and y. Okay, so you have again a coordinate system. This is y, this is x axis. So I cap means the distance that you have traveled along the x axis, that is 2. Okay, so this is your vector 2I cap. Okay, just like we cannot add, okay, just be with me, that just like we cannot add x coordinates with the y coordinate. Okay, if I say that there is a distance, let me show it here, that this is the, you can say, a point in the space whose point is p, whose coordinates are 2, 3. So meaning of this is that in the x direction you have moved 2 distance, and in the y direction you have moved 3 distance. Okay, so you have arrived at a point p. So this phenomena, if I have to represent this in vector form, meaning of this is that in the x direction, since I am moving 2 units, so in vector form I will write this as 2I cap, and 3 units I have moved in the y direction, so this I will write in the vector form as 3j cap. So 2I cap plus 3j cap, it simply means that there is a vector which has moved 2 distances in the x direction and 3 unit distance in the y direction to arrive at a certain point or to arrive at a certain position, right? So this is, let us say, 2 units, and this is, let us say, 3 units. So you get a position vector. Now I have used the term position vector. So position vector is simply the vector, right, such that you have arrived at a certain position by moving distances 2i cap and 3j cap in the corresponding, let us say, x and y direction, right? So it simply means that you have arrived at a position P from origin O. Okay, this is 2i cap plus 3j cap, and you can also write as 2 comma 3 just to show that this is the component in x direction 2 and in the y direction it is 3. Okay, so this is a position vector OP, which is denoted by 2i cap plus 3j cap. Okay, here only I have introduced the concept of position vector. Okay, so position vector is just a distance of a point from the origin. If I say, what do you mean by position vector? In simple words, it is a distance of a point which is at a certain position in the two-dimensional plane from the origin, right? In fact, since we are dealing with vectors, so if I have to take the magnitude of this vector, right, what I have to do is I need the distance, this OP. I need this distance OP, which is denoted by R. Okay, so how I can find out the distance OP? It is just by applying the Pythagoras theorem. Okay, how can I apply the Pythagoras theorem? Since this is the 2 units in the x direction and it is 3 units in the y direction, so applying 2 square plus 3 square under root, which is root 11. So here I will get value of this R as root 11, which is the magnitude of this position vector OP. And this magnitude of position vector OP is written by vector OP with these two vertical lines. Okay, I think all this you must have discussed already in IGCSE syllabus. It is just the revisit of these basic things in the vectors, right? So position vector we have covered. All right, so where were we? Yes, so there is another way of writing the vector in component form. One way of writing a vector in component form is writing just like I did here, the 2i cap plus 3j cap in this component form, or simply I can write this with a vertical matrix of 2 by 1. There are 2 rows and single column. Writing the first element, that will denote the x component, and the second element will be the y component. Okay, so 2, 3, this column vector is, this column matrix is called as the column vector, right? This may also be written as 4i plus 2j. Okay, this is a 4 distance, this is 2, this we have already covered. All right. So illustration 1 is that we have to write the vector A. Sometimes vector is written by this with an arrow like this, or you simply in the textbook it is written using bold letters, right? So write the vector A 4i plus 2j in magnitude and direction form. Basically we have to find out its magnitude and direction, or we have to write in r comma theta form. Okay, so it will be like this, that 4 you have traveled in the x direction, so this is 4 units, and this is 2 in the y direction. It means this vector, for example. Okay, this is 4 units and this is 2 units in the y direction, right? So basically finding out the magnitude of this vector OP, this is P, this is O. So magnitude of this vector will be 4 square plus 2 square under root. Okay, this is 16 plus 4 sorry, 2 square. So root 20 is the magnitude, which is denoted by small r, and then we have to find out the angle. Now for the angle that it is making with the positive x direction, you can apply the tangent rule, means tan theta, right? Since opposite and adjacents are involved, so opposite and adjacents are only in tan theta, right? So in this triangle, if you apply tan theta, you will get 2 by 4, opposite upon adjacent, right? So this is half, so theta you will get as tan inverse half. Whatever is the exact value of this, or the approximate value, you can write down the magnitude. Okay, so here you can write this, its magnitude form is root 20 comma tan inverse half. In the exam you will write the angle in point form, approximate value up to 2 decimal places. So this is the magnitude direction form. Okay, and also in case of writing the magnitude, if this theta is in the, let us say it is obtuse. Okay, so what we will do in those cases, right? So next examples, for you couple of examples will be based on deciding that theta will be negative, positive, acute or obtuse. Okay, so here we have to write the vector in component form. Now the magnitude and theta form is given, angle form is given, we have to write in component form, means I and j cap form, right? So here what we will use is we will go in reverse, that we have been given the value of r, which is 5, and theta is given as 60 degrees. Okay, so if let us assume that we are talking about a vector OP whose x component is x and j component is y, whose I component is x and j component is y, right? So if I'm talking about the magnitude r, it is given by x square plus y square under root, squaring the x component plus squaring the y component and under root. So its value is given as 5. That means from this equation I can square this. So x square plus y square is 25. This is your equation number 1. Now second part is, since there are two variables involved, x and y, so we need two equations. So first equation is the magnitude one, and second equation we will get using the tangent formula or the angle formula. So since always theta is given by tan inverse y by x, as we have witnessed from the previous example, if I take the tan theta, okay, you have been given a triangle, this is your theta, so this is y component, this is x component, so tan theta is y by x, so theta is always tan inverse y by x. So divide the corresponding y and x component of any vector, you will get the angle, okay, or the direction. So theta in this case is tan inverse, tan theta is y by x, that means theta is 60, it is given, so tan 60 is y by x, 60 is root 3, so I will get y as root 3x. Okay, this is your equation number 2. Now we have equation number 1, equation 2. What I can do is I can square this equation 2. So this y square is 3x square, right? And I can put this y square back into equation 1. This is simultaneous equation. So this is x square plus y square is 3x square is equal to 25. This is 4x square is equal to 25. That means x square is 25 by 4. Now here is a very interesting part, which is that if you find out the value of x, you will get the two values of x, right? Whenever we take the square root, there is always a plus minus sign outside the square root. That is only because there is x square. Okay, so if I take the under root on both the sides, I will get plus minus 5 by 2, right? So if x is, I take plus 5 by 2, right? What will be the y? It will be root 3 5 by 2, right? And if x is minus 5 by 2, y will be minus root 3 5 by 2. Okay, so if x is 5 by 2, that means y is root 3 into 5 by 2, right? Or x is negative, that means y is also minus root 3 5 by 2. Okay, now what values of x and y I should choose? There are 4 possible combinations. What should I choose? Right, that will be decided by the angle. So again we have to revisit the diagram. Okay, Since in the question, if you look at the question, magnitude was 5, but angle it was given as 60 degrees. Okay, let me make coordinate axis, things will get more clear. So you have been given the coordinate axis like this, and there is a vector, let us say like this, OP vector. This is P, this is O, and this magnitude is 5, and theta is making as 60 degrees. Now this is the information that we have to fetch from the question, that since theta is 60 degrees, that means it is in the first quadrant. If the vector is in the first quadrant, that means both the x component and y component are positive, right? If theta is, let us say, obtuse, then that means that you are in the second quadrant, and if you are in the second quadrant, it means x is negative and y is positive. So out of these 4 possible values, what values you have to choose, that will be decided by the angle, which is either acute or obtuse, or maybe reflex also, right? So since it is in the first quadrant, that means both x and y should be positive, right? That means I will take only this solution, that x is 5 by 2, that means y will be root 3 5 by 2. Okay, let us take another example to clarify this point. Again, it is like the same question, but here, as you can see, theta is not 60 degree, it is much greater than 60. Okay, so let us quickly solve this. Again, we have to find the values of x and y. So writing straight away that x square plus y square, all right, let me write it formally, that let OP be a vector which is of the type xi plus yj cap. Vector magnitude is r, so this is x square plus y square is equal to 10 square, so this is 100. This is my equation number 1, right? And theta is 290, that means tan of 290 is y by x. Okay, so whatever is the value of tan 290, that you will calculate. Okay, let me quickly give you the value of tan 290 using my calculator. Tan 290, sorry, is minus 2.74. Okay, so this is minus 2.74 is equal to y by x. That means y is minus 2.74x. That means y square is 2.74 is square minus into x square. Okay, so if I square the answer, that you will get 7.54. So y square is 7.54 x square. Putting this in equation number 1, this is your equation number 2, I get x square plus 7.54 x square is equal to 100. Okay, that means 8.54 x square is 100. So x square I will get as 13.247. Okay, and if I take the square root of this, I will get two values, which are 3.639, or simply I can use 3.64 plus minus. Okay, approximate values. So if x is plus minus 3.64, you will get y as some plus minus something, whatever is the value, right? So again, since theta in this case is 290, so 290 means it is in the fourth quadrant like this. If theta, this is your theta, okay, this is your 290 degrees, right? So this is in the fourth quadrant. So if theta is in the fourth quadrant or the vector is in the fourth quadrant, it means x is positive but y is negative. Okay, so you take x as positive and y as negative. Those will be the components, and then you will write the final vector OP by taking the positive x component and negative y component. Right here you will use the positive values because you have introduced a negative sign. Okay, otherwise I have initially chosen xi plus yj cap. So whatever is the value of x and y, positive or negative, you just use the initial value. Okay, this is just to explain you that this y will be negative. Do not apply minus and then use the negative values of y. Okay, thank you.